In question 3, we're shown a graph with a region shaded, and the first part says write down the equation of L1. So L1 is this line here, and it says that it's parallel to the x-axis, and it cuts at 3. So if I were to walk along this line, my x-coordinate would always be changing and getting bigger and bigger and bigger in this direction, but my y-coordinate would always be staying the same. So the equation of this is y equals 3. Or you could think that its gradient is 0, because it's not rising, so it's just y equals 3, no x. L2 passes through the point 0, 4 and 4, 0. Find the equation of L2. A couple of different ways to do this. If you did it in my group, we would have done y equals mx plus b, and because we know it passes at 0, 4, this is the y-intercept, which means it's y equals mx plus 4. And then how would we find the m? Well, m is rise over run. So let's have a look. If I go from 4 to 0, I've gone down 4. And if I go from 0 to 4, I've gone across 4. So the gradient here is minus 1. So the equation would be y equals minus x plus 4. Or you could rearrange that as y plus x equals to 4. Either way would be fine for 2 marks. Question part C says the line 3 passes through the point 0, 4, has a gradient of 2. Write down the equation of the line 3. So this is a command term, write down, it means it should be quite straightforward. So the gradient is 2, so it's y equals 2x, and then it passes at 0 minus 4, this is the y-intercept, so it's y equals 2x minus 4. Next part says find the coordinates of the lines of the point of intersection between line 2 and line 3. Well, earlier we said that line 2 in part B we said was minus x plus 4, and this equation has got, line 3 has got the equation y equals 2x minus 4. So at the point of intersection, these two things would be equal to each other because they both equal to y. So we can say that minus x plus 4 is equal to 2x minus 4. And then minus x on this side, if we bring that over here, we'd get 3x, and then plus 4, if I bring this minus 4 over here, that would give me plus 8, so I'm going to end up with with x equals 8 over 3. So I get 8 over 3 for the x-coordinate, and then for the y-coordinate I want to substitute this back into one of these equations here, so let's put it into this one. So this tells me that y equals negative 8 over 3 plus 4. You could do that on a calculator, or we know that if we want to add the fractions they need a common denominator. So if I want to write 4 as something divided by 3, it would need to be 12. So if we add the numerators minus 8 plus 12, it's going to give me 4, and then end up with 3 on the denominator. But it's a calculator paper, so you could use the calculator there. 8 over 3 and 4 over 3. Write down the 3 inequalities that define the region shaded are in the diagram. Well, if we just flip back to this diagram here, we can see, I'll just do it on this slide, we can see that the region is less than this line. So this line we said was y equals 3. So the shaded region is bound by y being less than or equal to 3. So that's one of the inequalities. Okay. We said that line 2, the equation of line 2 was y equals minus x plus 4, and this time the region is higher than that line. So another inequality would be y is greater than or equal to minus x plus 4. And then the last line, line 3, we said the equation was y equals 2x minus 4, and this time the region is below that line. So we'd write it as y is less than or equal to 2x minus 4. So those are your 3 inequalities.